Over the past 3 years, at least 6 new major chip-building projects, including HSMC and QXIC, have failed in China. At least $2.3 billion went into these projects, much of it coming from governments, the documents showed. Some never produced a single chip. The projects, in the Chinese cities of Wuhan and Jinan, were supposed to churn out 14 nanometers or smaller chips made by industry leaders Taiwan Semiconductor Manufacturing Company and Samsung Electronics, both which have decades of chip-building experience. In fact, the Chinese companies were supposed to make the more advanced 7-nanometer chips within a few years. Hello and welcome to Strategy TLDR, a channel where we explain strategy concepts important for managing your business. In this episode, we look at why China lags in advanced computer chips manufacture, despite a determined national effort. The opening remarks you heard at the top of the episode were from a report in the Wall Street Journal in January 2022. The scale of Chinese government investments is much larger than the above instances. In 2014, there was a US $22 billion fund for investments in chip manufacture, and in 2019 there was a national semiconductor fund of about $30 billion. According to the same WSJ report. It also added that local governments also set up similar funds, and attracted by these, tens of thousands of Chinese companies registered their businesses as related to semiconductors, including some whose main activities involved restaurants and cement making. Back in 2016, the global strategy consultancy, Bain & Company, said that China's economic plans called for the investment of more than $100 billion toward attaining leadership positions in the semiconductor space. So, the scale and scope of above investments came as no surprise. Despite being the world's leading manufacturer of electronics that use microprocessors, memory, logic, and analog chips, China produces only about 17% of the chips the country needs, leaving China reliant on foreign producers. According to the above-cited WSJ report, not only the earlier reports, but the recent U.S. trade restrictions on U.S. and foreign chip manufacturers and equipment manufacturers on exporting to China clearly indicate that Chinese semiconductor manufacturers are still dependent and would need to catch up with leading foreign companies. What are China's challenges in high-end semiconductor manufacture? The Bain report lays this out very clearly. The first question for China as it chases chip leadership is where to enter the market. Memory, logic, or analog chips, fabless, foundry, or integrated business model. Each of these require foundational IP and ongoing innovation, as well as the engineering talent to sustain it. These factors are self-reinforcing, which is great for market leaders but makes entry difficult even for the most well-funded challengers. This challenge faced by China is called path dependency in creating capabilities. In simple words, it means, to create a particular capability, a firm must go through a long, difficult learning curve. There is no shortcut to the learning process. New firms must go through the experiences to develop the capabilities. What this implies in semiconductor chip manufacture is that there is no shortcut to the question, how to make it. The top semiconductor companies like TSMC and Samsung have invested a lot in developing the cutting-edge manufacturing process technology. They have acquired intellectual property or IP through investing billions of dollars in R&D. So, they are not going to teach or share the IP with competitors. This is illustrated by the accompanying graphics in the 2016 Bain report. China's SMIC, along with 17 other companies around the world, can make 65 and 45 nanometer chips, and with 11 other companies it is capable of making 32 and 28 nm chips. But when it comes to the smaller 14 nm chips, there are only 4 companies in the world: TSMC, Samsung, Intel, and Global Foundries that can make them. Fast forward to 2022, TSMC, Samsung, and Intel can make 7 nm chips, while TSMC and Samsung are reportedly on track with 5 and 3 nm chips. As the path dependency concept in the earlier Bain report indicated, SMIC of China and other aspirants have to learn to make the 7 nm chips competitively and at scale. This brings up the question, what about the news reports in mid-2022 that SMIC is shipping Bitcoin mining semiconductors built using 7 nanometer technology? Does that mean it has overcome path dependency? Subsequent reports have indicated that the 7nm process is a copy of the N7 node TSMC put into mass production 4 years ago. And this did not come as a surprise, as a number of ex-TSMC engineers work for SMIC. Dylan Martin, in a report in July 2022 in the Register, wrote that SMIC is likely using an older generation of lithography machines, called deep ultraviolet lithography, DUV, to manufacture 7nm chips. The implication is that while SMIC has the ability to make 7nm chips, it won't be easy. the company will have to deal with more yield issues than if it were using the latest extreme ultraviolet light (EUV) technology. For viewers' information, EUV technology is supplied by the Dutch company ASML, and the U.S. government has blocked it from exporting its technology to China. In a follow-up article in the same publication in August 2022, Rupert Goodwins took a deeper dive into the issue. He said, "Everything needs to be reinvented. The tools, the techniques, the lot. Every company in the game had to pick its own path through these problems. What China has looks very much like a one-off proof of concept that they can produce one particular chip in 7nm, not any chip in 7nm. It's also an ASIC crypto miner, highly parallel, low complexity. A starter chip. We're not talking an Apple M2 SoC." He highlighted an important point about the industry. The key to competitive chipmaking is scale. Once you have a commercial opening, you scale up as quickly as you can to take market in what can be a very short window. China's half-inch TSMC process cannot scale because, most likely, it doesn't have all the specialist expertise and tools that turn the process into products. This seems to be where we stand when the video is recorded in mid-September 2022. I hope this helped you to understand the path dependency in high-end semiconductor manufacture and the challenges China faces.